Right, so the first one, we have a frustum. It is basically a cone with the top removed. So it looks like this, this thing that you've seen during PE, right? This shape, what do we all call it? Cone. But it's not a full cone one.
Yeah, it's like a short cone.
Okay, then the proper name is called a frustum. Frustum. Because a cone is supposed to have a sharp pointy end, right? But in PE, the one don't have that sharp pointy end, so it's part of a cone only. Cone without cone. Okay, then you get a frustum. Okay, it is done by cutting off a small cone from the big cone. So find the height of Mn, from M to N over here. Now you have to realize that when you cut off the top of a cone from the original cone, we actually have, we can actually compare what was cut off. So assuming this was cut off, this is our VCD. This particular cone is similar in shape to the original big cone. Okay, this is one thing you must know. These two are similar. So all the properties of corresponding ratio of corresponding sides, areas, volume still applies. Okay, so now if I want to find the height of Mn, you can tell that as long as I can find the height of Vn, which is the height of this small cone, I can take the original value, minus away this value, and I get my answer. So that is the approach we're going to take. So now we want to find out the height of Vn. Okay, so height of the small cone. We have other information because there are similar solids over here. Our objective now is to find Vn. So Vn divided by the original, the corresponding height, which is Vm. Okay, small height divided by big height has to be equal to small radius, so that is Nd, divided by big radius, Md. You actually can go ahead and substitute in values over here already, but I'm just putting down the names so that it is clearer for you when you do your revision. So Vn is what we want to find. Vn divided by Mn, which is 8, equals to 3 over 6. Okay, so I know the answer for Vn must be 4 already. Half times 8, you get 4. So this height is 4. Therefore, Nm must be equals to 8 minus 4, which is 4 cm. So this is our answer for part A. Next one, for part B, ratio of the area. Now, we are talking about area. For area, please note, we are going to have the square ratio of sides if the solids are similar, which in this case they are. For the upper base to the lower base. So you want the ratio of this to this. Alright, so we are comparing small cone to the big cone, and they are similar. So the ratio of the area has to be square of ratio of sides, which we already have. So in part B, area upper over area lower equals to the square of the ratio of the sides. So the sides, you have option that you can choose 3 and 6, you can choose 4 and 8. Doesn't matter, because you're going to end up with half. So 3, 6, and I get 1 over 4. So since they wanted it in a ratio, so ratio, okay, let's do it properly. Area upper to area lower equals to 1 to 4. And then the next one, volume of the frustum. If the volume of the cone VCD, this part that was cut off, is 12 pi. So this volume equals to 12 pi cubic centimeters. Now they want the area of the frustum. But that frustum at the bottom, it is not a similar figure to that cone that was cut off. So we cannot compare directly. However, we can compare it by considering the original area of the cone. Then you take away the area, the original volume of the cone minus the volume that was cut off. I think you get the resulting, which is what they wanted. So in part C, write down volume. We want to find the original first. So volume of the big cone divided by volume of the small cone equals to the cube of the ratio of the sides. So this time I have the big one on top, 2 over 1. You can put 6 over 3, you can put 8 over 4, same thing. So we end up with 8. So the volume big must be 8 times of the small volume. The small volume is 12 pi. So we get 96 pi cubic centimeters. Therefore, volume of the frustum must be 96 pi minus 12 pi. Then you get 84 pi. But you need to round off to 3SF, right? Because the cover page says if your answer is not exact, you put it to 3SF. 84 pi is your calculator, find out value. Then I want you to write down 5SF first, 263.89. Then you round off to 3SF, 264 cubic centimeters. So this was our first homework question.
So I do everything in one method.
You do everything in one method, to see whether I can understand. Because it's your job to make me understand. If you understand but I don't understand, I cannot give you a mark. Okay? Anybody needs more time for this? Otherwise, I have an announcement to make. Yesterday, we had a question, whether we had to prove that triangles are similar in order to use the relationship. Okay, so over here, question 12a. Just to remind you, we wanted to find the area of ABC. So meaning this big triangle, and we are given the area of this small triangle ADE. Alright, so we recognize this shape, they are similar triangles. So the question is, do we need to prove in order to use this property? So I checked already. Typically this is 1 mark. 1 mark question only. You do not need to prove. However, you are encouraged to state which two triangles are similar. Just need to state, no need to prove. Okay? However, if this particular question is a 3 mark question, then you better prove. So you have to work smart. Look at the number of marks over there. 1 mark only, then don't bother proving. You just want to know the relationship. However, if it is a 3 mark, then go ahead and prove. But I just want to let you know that I've not seen a 3 mark question before. This has always been 1 mark. Okay? Now we move on to the exercise 3.4. Okay, first question. Question 3. Now ratio of area of corresponding faces of 2 cubes. So just take note right now in your textbook, when they talk about cubes, these are similar solids. Right? All cubes are similar solids. Because every single cube, they have the same ratio for their corresponding sides. Because it's a cube, there is only one dimension. Similarly, every single sphere is similar. Whether it is a big sphere, small sphere, they're all similar solids. Okay? Now, they want us to find the ratio for the corresponding sides. So part A. Side, they started with the big one, so side big divided by side small. Now the side is going to be the square root of the area big over area small. Does this make sense to you? Right? When we want the ratio of area, we square ratio of side. If I want the ratio of side, I square root ratio of area. So this gives me Square root 49 over 36, which is simply 7 over 6. Therefore, for part A, ratio equals to 7 to 6. Work with fractions, it is way more convenient for you. Moving on to part B, ratio of the volume. So volume big over volume small. Notice how I write my short form. Give it a name, whether I'm doing the side, whether I'm doing area, whether I'm doing volume. These are big, I write them in a bigger size. And then the extra description, the further description, tiny letters, bottom right corner, saves you time compared to writing volume of the big cube divide by volume of the small cube. I always want to help you save time, trust me, this works. Carry on. So volume is now the cube of the ratio of the sides. So this is the side big divided by the side small. Okay, we could have skipped this step. You can just substitute in the values. Okay, move this side big to side small. 7 over 6. Please make sure you have the brackets over here when you're doing the cube. So 7 divided by 6 with power 3. So 343 over 216. Therefore, ratio equals to 343 to 216. It's part B. And then now part C. They tell you that volume of small cube 648, find volume of bigger cube. Okay. Very conveniently, we can use what we already found. Volume big divided by volume small. We put what we want to find out in the top left hand corner of the fraction. Always makes life easier. Divided by 648, this has to be 343 over 216. So carry on. We want to get rid of 648. This over here, don't want. I only want volume big. So to get rid of a divide by 648, you multiply by 648. On the other side, you also multiply by 648. Resulting in volume big equals to 343 216 648. So 1029. Okay, then just make sure the numbers make sense to you. The volume of the bigger cube. Okay, I got 1029. Just quickly check out the small cube 648. Makes sense. Volume of the bigger cube is bigger than volume of the small cube. You okay? Anybody needs more time for this? Otherwise, I'll erase cause not enough space. No need, Presentation, very important. Question 5. Pentagonal prism. Height 25. Base area 170. Find the volume. Okay, so recap. Volume of a prism. Base area times perpendicular height. This is the base area. This is the perpendicular height. So 170, 25. 4250. Then B part 1. They tell you now, similar prism, height 30. So I need to compare this 30 with the 25. Since the similar prism has a height 30, it is bigger. This is the smaller one. Find the base area of the bigger prism. Okay, so area big over area small. Always compare the same thing. Then this will be the ratio of the sides, but we square them. So side big divided by side small. Substituting values. Area big divided by area small, 170. Side big, 30. Side small, 25. Square it. Area big. 30 divided by 25. So inside this fraction, it is 6 over 5. We square it. Then we multiply by 170. 244.8. So just double check, make sure your answers make sense. Area big 244.8, area small 170. Okay, yeah, it makes sense. You cannot have a big area, supposedly big area, ending up as a smaller value compared to 170. And then finally for part 2, volume. Volume big, divide by volume small. Same thing lah, 30 over 25, we simplify it, it becomes 6 over 5. Cube. So volume big equals to 216, 125 multiplied by the small volume, 4250. 4250. How much? 7344. Okay. Do you check the answer at the back? Okay. So that's it for question 5. If you need to copy, focus on the presentation, how you present, and really convince yourself that the steps are just like that. No? We don't have anything very fanciful, very complicated. JV, have you done your work? Have you done your work? Can you help us with the start for question 6? Meanwhile, the rest need more time, raise hand, otherwise I'll erase. Okay, so JV, you have done your work, huh? Can you help us start for question 6? A. Louder a bit, louder a bit. Height, so height, tall, like this. Huh? Tall one, what do I write? Height, H-E-I-G-H-T. Tall, is it? T-A-L-L? Well, how about you use B lah? B is given, right? We don't need to name it when there is already a name. Okay, so make a small edit. So height B divided by height A. Okay, height A. Okay, then? Huh? Oh, equals to 15 over 10. Okay. Then? I have to simplify. 3 over 2. And then what happens? Huh? Must square the answer. What do I write? What should I write? Right area. Area. Right area what? Huh? Area B over area A. Square. Oh, it is equal to 3 over 2 square. Okay, I have you this one, 9 over 4, and then? Write the equation. Tell me what to write lah. 9 is to 4, huh? So 9 is to 4. 4 is to 9. So just like this. Does it look a bit strange? A bit strange, right? Like, why why the 4/9 suddenly appear like not attached to anything? Okay, so what should I write? Ratio. Ratio A is to B. Huh? What is it? So do you still want the word ratio? The one. Okay. So what do you want me right now? Base area of A. Oh, come on, one last line. Of base area A. Of A. Huh? The dot dot, okay. So base area of B equals to so do you do your work or not? You look like you are reading out whatever Christopher told you, whatever Musfira told you. So do you do your work or not? Never do, right? Never do, still want to doze off. It's not helping yourself, if you continue like this. Okay? So how do we improve on this? This is correct, full marks. How do we improve on this? Look, the question wanted base area of A to base area of B. So I think it would be better if we start off writing the height of A over height of B. Just a slight change only. And this gives us 10 over 15, which is 2 over 3. Now in fact, we can even go ahead and say, hey, since I want base area A to base area B, let's make some more changes. I want to talk about height. Since they want base area, I give you base area. So area A divided by area B. This is the square of height A over height B. So area A divided by area B, then it's the same. Yeah, just write area A, area B can already. I don't need to write the word base. Because regardless of which base you're using, curved surface area, flat surface area, total surface area, the ratio is still the same. Still area. In fact, the word height over here that I'm using, sometimes when I get so lazy, right, I just write side, side, side. I just keep writing side. Even though it is a height, even though it is a length, even though it is perimeter, I just write side. Because it doesn't matter. S-I-D-E. S-I-D-E. Side. Corresponding sides. Okay? But to give more context, you can be more precise with your presentation. So height A over height B, 10 over 15. Then you square this, you get 4 over 9. Then final answer here. Okay, Javier? Part B, capacity of A to capacity of B. Now capacity is related to volume. So it's asking for the amount. The amount of space that it has. In other words, its volume. So for part B, I'll show you how I will now edit the work that we've done in part A. Can I erase part A already? I just make small changes only. Instead of area, we now want volume. Instead of square, we have to cube. So 2 cube is 8, 3 cube is 27. And then volume A to volume B. 8 to 27. Okay, since they wanted capacity, right, I'll be more precise, capacity. Capacity A to capacity B is 8 to 27. Okay, questions? No, move on. Did I give any more? 7, 8. But those were not homework questions. So let's do this now together in the class. We've got two similar solids, same material. When they talk about material, please help me circle the word material. Same material is about density. They are going to be talking about mass and volume already, okay? So related to density. In other words, volume proportional to mass. The greater the volume, the greater the mass, by the same time. So the base area in the ratio 25 to 49. Must be very sensitive to numbers. 25, 49, they are square numbers. Base area is 147 for the larger solid. So this is 147. Put it down in your diagram if you need to. 147. Find the base area of the smaller one. Okay. Put it on the right side. Area small over area big must be the, it's given 25 over 49, and then the area big was given to be 147. So area small is simply 25 divided by 49 times 147. 75. Giveaway question. Giveaway mark. Part B. What is the ratio of the heights of the two solids? Okay. Height small over height big. This will be the square root of area small over area big. Has to be. So area of the ratio of the area small, area big, 25 to 49. So we get 5 over 7. So ratio equals 5 to 7. Final part, the mass of the smaller solid, 8.25. Mass of larger solid. Mass, they want to find large, so put a bigger one on top, divided by mass, small. This is, you treat it the same as volume, because mass and volume are directly proportional for constant density. So for volume wise, we are going to have to cube the ratio of the side. The ratio of the side was 5 to 7 for small to big. This time I want big to small, so 7 over 5. Substituting the value for the small mass, 8.25. So mass, large, big, large, same lah. So 7 over 5 cube times 8.25. 22.635. 638. Exact value, yeah? 638. And you verified with the answer at the back. Okay. So this is the big one. One last question that I wanted to go through in class. Okay, so spend some time reading it first. This is question 9. Right, so mass, large. That is what I want to find. I put it on top. Divided by mass small. This is going to be the cube of the ratio of the side. But do I have ratio of side? Yeah, I have. Large 20. Small 15. So mass large must be 20 over 15 power 3. Let's see what that gives us. 20 divided by 15. 4/3 power 3, 64 over 27 times our 405.
960.
Yes, 960 grams. Done. Okay, so we finished the homework already. We finished this topic already. Finished chapter 3. But I have one last thing I want to tell you about. Okay, in case you're still copying, give you some time first. Derek, finished? Okay, now, same question, question 9. I'm going to make some change. Watch carefully. Then you think about how to do it. Have instead of pi, right? Have base area 15 square cm, 20 square cm. How to find the mass of the larger one? Okay, so instead of giving you the heights, I give you the area. And I conveniently just leave it as 15 and 20 lah. So how? Okay, think about it. It is square root what? Square root of 15 over 20, is it? What are you trying to find? Find height. Are you sure you're finding height?
Find the ratio.
Keyword is ratio. Ratio of height. Okay, tell me height. I mean, it might be height. It might be the perimeter. It might be the diagonal length. I don't know lah. So let's just call it side. Okay. Ratio of the side. So side. Since they started off with a small area, right? Side small divided by side big. Okay. What is this equal to? Square root 15 over 20. And then what do you do with this? Don't want to press calculator. Sure don't want? You press the C lah. Why don't want? 15 divided by 20. Yeah, horrible number lah. We don't write this down, right? Leave it like this. Okay, then what do we do next?
Find the mass of the larger one.
Cube, right? Cube this one to find ratio of what?
Ratio of the
Volume?
mass.
Mass? Whether it's volume, mass is the same, isn't it? We don't want to write ratio of volume lah because waste time. Straight away, volume ratio of mass. So mass small over mass big equals to 15 over 20 with the square root, but this time I have to cube it. And then you know the rest already, right? So this is an example of what could come out. If you don't want to make things too direct for you all, I got a feeling this type of question will come out. Okay, for your media exam.